Welcome to the Water Channel podcast, a series of conversations on water, food, and agriculture. We feature stories and insights that are defining our present and are shaping our future. I am Abraham Abhishek. We call the Earth the blue planet because when seen from space, most of it, 71% to be precise, is seen to be covered with water. But almost half of the water that we drink, 40% of the water we irrigate with, and a third of the water used in industry comes from the brown bit, the land part. This, of course, is the groundwater, which lies and flows below layers of rocks and soil, which comes out through springs, out of wells, and out of pumps. 2022 is the Year of Groundwater, and this is reflected in national and international organizations around the world putting groundwater front and center this year, in their discussions, their policies, and their actions. The slogan for this Year of Groundwater is making the invisible visible, highlighting the fact that groundwater being under the ground is out of sight and out of mind, even though it's 98% of all fresh water which is available, accessible to us, and even though we are so heavily dependent on it. The invisibility of groundwater makes it difficult to measure and monitor. And what that has resulted in is indiscriminate extraction and undetected pollution of aquifers, which is what we call repositories of groundwater. The stress, the demand on our aquifers is increasing, with increase in population, with climate change, and with surface water sources shrinking. So this is as good a time as any other to talk about groundwater. To do that, we are lucky to have with us Dr. Elisabeth Lichtwoud, a noted hydrologist who since early this year has been the director of UN IGRAC. So that's the International Groundwater Resources Assessment Center, which is a UNESCO Global Groundwater Center. Elisabeth, thanks a lot for joining us. My first question is, groundwater is obviously under the ground. So how did we as a species or as a civilization first figure out that there lie huge amounts of water under the ground?
Very good question. There is a lot of indicators in the nature that we have water under the ground, So first we have to observe. But, for example, the springs are just groundwater discharge, We have also to observe the rivers when they still flow after several months without rains, etc. We have to observe also the vegetation. Some trees are dependent on groundwater, etc., depending on the species. But an hydrogeologist is first a geologist that studied groundwater. So first we have to understand the geology, because groundwater cannot be everywhere. It depends on the geology. So you have some geological formation, some rocks that can store groundwater and transmit groundwater, but some not, that are really not permeable, that do not allow groundwater to pass through, to be stored and to pass through. So first we have to know the geology, understand if we have here rocks that can store and transmit water. This is the first step.
We refer to groundwater as invisible water, and that makes sense because it is invisible and we cannot see it. But at the same time, we use it a lot. I learned from IGRAC sources that 40% of all irrigation happens with groundwater. A third of all the water used in industry is groundwater. And half of all the water that we drink all over the world is groundwater. So how can we use something so much? How can we be so heavily dependent on something and still think of it as invisible?
It is because more than 95% of the global fresh liquid water is stored underground, is groundwater. So surface water is just less than 5% of all the planet fresh liquid water, So basically, when there is not enough surface water for all the uses, people automatically start digging wells and looking for groundwater. And there is big volume of groundwater, so this is where starts the problems.
Surface water sources like lakes, ponds, rivers, anybody can go and draw water from them, even with a bucket. To get to groundwater, one has to get through layers of earth and rocks. So we need some money, some investment, some machinery to drill through, some manpower, some technical expertise. Does that make groundwater more accessible to the elite and less accessible to others?
Yes, you are right. Groundwater is an access issue. Before, in more ancient times, groundwater was access, means were more or less the same for everybody who wants to access groundwater. But today, if you are able to dig a deep well, if you are able to install pump that can extract groundwater from deep. So of course you have access to more resources than farmers and small users that have a well maybe 10 meters deep and will not be able to dig ever more. So yes, for those people, the well dries up when other people have no problem at all because they still have plenty of groundwater.
How is the state of groundwater right now, like globally? Does it even make sense to talk about groundwater at a global level? Or as a resource, is it very localized and fragmented? For example, is the state of groundwater very different in Eastern Europe than it is in Western Europe, than it is in Indonesia? Or is there a logical way to talk about groundwater globally? And if yes, what is the state of groundwater globally? Are we doing a good job managing it, or are we not doing a good job?
As all water problems, groundwater is also very local, no? But when you start having problems, groundwater problem or water problem in more and more places around the world, more and more local problems all over the world, you can start saying that globally there is a problem, no? So basically there is regions, all over the world where groundwater is depleting faster than others, in United States, in India, in Middle East, so you start having really groundwater depletion in some aquifers. But we cannot, of course, have a global overview. I mean, we cannot say globally groundwater is depleting, no, because you have aquifer that the groundwater levels are stable, but some aquifers where groundwater, is depleting. So, but globally we have more and more aquifers and local problems on groundwater.
So where are some of the hotspots? Where is the situation really bad?
The situation is bad, in some region of United States, in India, in the Middle East, all the Middle East, especially in the most populated arid and semi-arid areas, because, there all the users depends on groundwater because there is, in arid and semi-arid area, there is almost no surface water. So in those places, those are the hotspots.
And in those hotspots, what are some of the biggest drivers, some of the biggest users of groundwater?
The biggest use of groundwater is irrigation, Usually the problems, aquifer depletion, is because of overuse and overextraction, especially for irrigation. It's not everywhere, but as a general statement, we can say that.
Are there also parts of the world that are doing a good job managing their groundwater resources?
Yeah, of course. There is good experiences and in all those places, we can find good practices that are still to punctual, Groundwater needs governance, and there is still many challenges about groundwater governance because at the end, the story of groundwater development is more recent than water development and water management. So we are starting seeing problems, and this is where we have problems that we have to start to manage. So groundwater governance is a challenge because we cannot manage groundwater as we manage water. Groundwater has its own specificity, but then we can find good experiences in those. Even in India, in Europe, there is some interesting initiative to protect groundwater, not only the quantity, but also the quality. Contamination of groundwater start to be a problem in many places of the world, and this is now a big concern.
So what kind of groundwater quality concerns are we referring to here? Or rather, how does groundwater get polluted despite being under the ground? If you could explain that a bit.
In general, groundwater is much less vulnerable than surface water because it is under the ground. So even if the groundwater is shallow, at least if you have soil under the groundwater, water will be filtered before reaching the aquifer. However, in some cases, shallow aquifer or aquifers that groundwater that is held in some rocks that have very big opening and like caves, In this kind of aquifers, contamination can go very fast, reach the groundwater very fast, or if it is very shallow. Contamination comes, from the surface, from agriculture, from industry, from even residual water from cities and settlements. So there is many sources of groundwater contamination. One of the big concerns today is nitrate contamination, for example, coming from agriculture and fertilizers. You have also natural contamination of groundwater because when the water circulates through the rocks, minerals are dissolved, and then you have those minerals in the groundwater, which can be good, but also some minerals are not welcome for our health, like arsenic. And for example, in Bangladesh, there is a lot of arsenic problem to a level that is really harmful for the health, or fluoride. But those are very punctual places. The concern, is more about big aquifer contamination from anthropogenic contaminants.
It seems that for good groundwater management, you need technology. But based on what you said earlier, it seems that good groundwater governance is also important. So taking both these things into account, is there a difference between how well developed countries are able to manage groundwater resources and how well developing countries are able to manage them? Is there a difference between the two?
Yeah, there is in some way problem of resources, of course, because to manage water, groundwater, any resource, you need data and you need information. So you need to generate data and you need to generate information. So this is the first limiting factors, where especially from a resource that you cannot see. So it is sometimes difficult to understand that we need data, we need understanding the groundwater processes, the groundwater situation in order to take good decision. So this is the first limiting factor for the countries with less resources. And then, of course, access to technology is a limiting factor. Yes, to have strong institutions that are able also to put a framework to manage and govern this hidden resources.
What kind of tools do we have at our disposal to monitor groundwater, to measure the size of the stocks, to assess its quality? And has our ability to do so improved over the years?
Different tools. In general, we need wells, and we need to measure the depth of the groundwater below the ground, no, in those wells. So first, we need the wells and so to be able to directly measure groundwater. Then there is other technologies, no, that and today. Yes, you are right. Groundwater monitoring has improved in a lot of countries. And there is some remote sensing approaches to monitoring, which are still not very well, still in progress. Yeah, this is something that we cannot only use, and we need ground data still. But there is improvement in that. But this is not the only thing we need. The problem of groundwater is, in water it's also the case, but more for groundwater. We don't need only groundwater measurement, depth of groundwater measurement, but also we need to understand where the recharge comes from, to know how much is the recharge of groundwater, to understand how much also we can extract. We need to understand the volume, so this is a big part of geology also there. But the very important data that we are lacking in a lot of countries, even in some more developed countries, it's the total abstraction. How much extraction of groundwater, and this is where the governments have a big role to play, of course, and this is a governance issue to control groundwater abstractions, and this is where, you need resources, of course, for controlling, and you need a clear framework to be able to understand the situation and to monitor and to put limits also. And for the quality, it's also a challenge because you need to take samples, you need to analyze water. So this is where we have even less data on groundwater.
What's the source of abstraction data? Is it usually users who report how much they abstract?
Yes, in general, this is reporting. They have to install a meter. It depends a lot on the countries, but in many countries is through meters and reporting, and then also controls by the state.
How much of a complicating factor is the fact that a lot of aquifers run across international boundaries, or to be more accurate, a lot of international boundaries run through aquifers?
Yes, this is a challenge. First, there is a challenge, as I told you. In order to manage groundwater, we need to know groundwater depth and evolution of the abstraction, recharge, discharge, etc. We need to understand all the processes that recharge groundwater and then the discharge. When an aquifer is under different countries, several countries, this is even more complicated because we need to understand really the processes, the flow within the aquifer to know if abstraction or in one country will affect the other. No? So we really need to understand the flow processes underground. Of course, the flow can come from far away, and the recharge can come from far away, pass through the border, and etc. But sometimes, of course, you can have an aquifer, transboundary aquifer, but maybe the abstraction in one country will mobilize flows that are more local, so it will not affect the other. And this calls for data, understanding, and assessment and knowledge generation. And so this is where is the challenge. Now, with this information, then we can manage correctly. But this is even a more challenge between 2 or 3 countries.
2022 has been designated as the Year of Groundwater. Why is this a good time to think about groundwater, to talk about groundwater, to work on solutions to problems related to groundwater?
This is a good time because first, we are in the water decade declared by United Nations, starting 2018 to 2028. And next year, 2023, will be the midterm of this decade. And there will be a UN Water Conference in New York in March 2023 to review this midterm of the decade. So this is a very good time because we really need to mainstream groundwater in all other water issues, because we will not solve any water issues without taking into account groundwater. So this is a very good time to generate messages, to work on priorities, and to try to bring groundwater and those priorities that we have to work on to the midterm conference on water of UN next year. And this is a good time also because we are in 2022, also regarding the SDGs and the 2030 goals. So groundwater should really be taken into account regarding the SDGs, regarding climate change. Yeah, we are at the right moment now to really make the world knowing this issue and taking into account groundwater in all other water issues.
Something that is unfolding right now and that affects all sectors is climate change. In fact, we are now even calling it a climate emergency. So in the context of climate change, what role can groundwater play to help communities cope with the effects of climate change?
Groundwater can really play a big role. Groundwater flows processes are much slower than surface water. When water flows through rivers within days from source to sea, groundwater takes years, decades, millenniums even. Yeah. So this means that this is not because it's not raining 1 year that you will have a problem on groundwater. 2 years. And depending on aquifer, even when you start seeing that groundwater depletion or problems with groundwater, that means that the pressure started maybe 10 years ago, 20 years ago, when you start seeing the effect on groundwater. Yeah. So this has good things and bad things. The good thing is that if we know well both resources, surface and groundwater, during drought, we can use groundwater because it's there, and then when it's raining again and we can leave groundwater, let recharge groundwater and use surface water because it's raining. We will have surface water. It's a short example, but to understand how we can manage both resources and use groundwater as a buffer against droughts. The bad thing is that if you are depleting groundwater, the time to get back to the initial situation will be at least 10, 20, 30, 50 years, You will not have your groundwater recharge in 1 year. Yeah. So this is a buffer against drought. This is clearly a resources that if we manage it well, will allow us to go through those droughts and allowing to recharge when we have. And there is now a lot of work on how to improve recharge artificially, of course, but through what we call now nature-based solution, meaning that when it's raining a lot, trying to recharge groundwater naturally. So we store groundwater, we store water underground, and we keep it for the drought seasons.
Given where things are at the moment with respect to groundwater, and given what seem to be the most promising approaches and solutions at the moment, what is going to be at the top of IGRAC's agenda over the coming years? What will be your priority areas?
Yeah, for IGRAC, a big priority is data generation, information generation, and assessment. We are a global center, so we are working at global level, but supporting countries, regions in the monitoring of groundwater. This is a first priority that IGREC has been working now for years, and we really still need to work on it because there is still big data gaps. No? Then other priorities, of course, are groundwater quality in general, but what we really need to focus also is advocacy to be able to mainstream groundwater in all other water issues, because as I said, we will not solve any water issue without groundwater, and how we really reach the practitioners, the countries, the policymakers, so they can take the good decisions based on data, based on a good understanding of their groundwater resources at local level. This would be our priorities.
Thanks a lot, Elizabeth. That was a great overview of where things are at with respect to groundwater and why this is a good time to bring urgency to our thought, to our talk, and to our action around it. We will follow very keenly all that is happening this year, this so-designated Year of Groundwater. We look forward to learning a lot out of that process, but more importantly, we hope that the Year of Groundwater also turns out to be a watershed year for groundwater research, groundwater governance, and groundwater management. We sincerely hope that 2022 is the year when things take a turn for the better. Thanks for listening.